Now, Jay, you've got a pretty hard problem here, so I thought I'd make a little show me for you. In the case of problem number 32, it's fairly easy to figure out the rate order for S208. You can look at experiments, I think it's 1 and 2, and the concentration of iodine does not change. The concentration of S208 goes up by 1.5 times, and I think the rate goes up by 1.5 times. So it looks like the rate order for S208 is a 1. Now, the problem with finding out the rate order for iodine is that there aren't any experiments where the concentration of S208 remain the same. So you're forced to use a slightly different technique, but it's where you can compare the rate for one experiment to the rate of another experiment. So I have the rate set up from experiment 3 compared to experiment 1, and obviously rate 3 is equal to the K value times S208 raised to the first power, we've already established that, times iodine raised to some power x, we don't know, that's what we're trying to figure out. I'm going to compare that to the rate from experiment 1, which is equal to, of course, the K value from experiment 1, S208 raised to the first power, and iodine raised to the x power. Now I'm going to substitute in values for the rate of 3, the rate of 1, the S208 concentration, and the S208 concentration from number 1. And I'm also going to eliminate K3 divided by K1. Since they're both constants, they should have the same constant, they should cancel out. Okay, I've substituted in the rate from 3 and the rate from 1. The K values canceled. I have the concentration of S208 from experiment 3 raised to the first power, the concentration of S208 raised to the first power from experiment 1, and I've substituted in the concentration of iodine from the third experiment and the concentration of iodine from the first experiment, and they're both raised to the x power. I'm just going to do a little math here and try to simplify. Now this divided by this is going to be easy to simplify. That's equal to 2. So I can get rid of all this garbage here and say basically that one number raised to the first power over the other number divided by the first power is 2. Also, 0.054 divided by 0.036, this point out here, that I believe is equal to 3. So I'm just going to simplify that by dividing. I'm saying that that is equal to, if I can clean this up, 3. I can also divide 0.054 by 0.036, both raised to the x power, and simplify that. And that should be something like 1.5 raised to the x power. Now you can do your algebra, divide both sides by 2. And so on this side you get 1.5. On the other side you get 1.5 raised to the x power. And so obviously the value for x here is a 1.